Welcome to the Siemens Technical Education Program course. This course covers Siemens PLC basics, additionally to teach you about the PLC configuration and logic functions with Step 7 software. Before going to logic functions, we will see the basics of Siemens PLC. PLC means Programmable Logic Controller, also referred to as Programmable Controller. A PLC monitors inputs, makes decisions based on its program, and controls the output to automate a process or mission. For example, take two push buttons and output. Here my output is motor. We will develop a logic when to stop or when to start my output. The logic is in the logic function topic. We will see how to create logics. Now we will see different range of Siemens PLCs. Now first we will see low range PLC is in the Siemens that a low range is S7200. This is compact PLC and low cost. This PLC is used in small systems. Compact means limited number of IOs and memory. Now if you go for a medium range is S7300 series. S7300 is a modular PLC and wide range of IOs. That means we have number of IOs expansion in the rack, but there is a limited memory, limited range of field buses. In high range Siemens PLC S7400 series, this PLC is redundant architecture and a large memory, high performance, large number of IOs. In Siemens PLC we have new CPUs, that is 1200 series and 1500 series. The 1200 series is low range PLC and compact, low cost, and this PLC is used for small systems. And another one is 1500 series. This is medium and high range new CPU. This CPU is modular and wide range of IOs, large memory, high performance CPUs. Now we will see Siemens PLC communication protocols. Mainly in Siemens they use MPI, multi-point interface. For MPI, number of nodes is 32, and Profibus, number of nodes is 126, and Profinet. In MPI we can see in the network how this is connected. One node means S7300 is node 1, S7400 is node 2, S7400 another one is node 3, and this PC is node 4 and HMI is node 5. Like that, total 32 nodes we can connect. When it comes to the Profibus, we can connect 126 nodes, and in Profibus we can see the remote IOs and HMIs, PLC, different field bus we can connect. Now we will see the Siemens PLC configuration. In the configuration, arranging the Siemens module, there is only two rules. The power supply module must be plugged into slot 1, and IM interface module in the central mounting rack must be plugged into slot 3. You can see here there is a total 11 slots. In slot 1 should be power supply, and slot 2 is CPU, and slot 3 should be interface module. Remaining modules, functional modules like input module, output module, anything, analog input, analog output. We will see this configuration arrangement with Step 7 software. To develop the logic, PLC logic, we need to know what are the PLC programming languages. According to IEC standards, we have textual languages, graphical language, and sequence language. In textual language, the instruction list, it looks like the programming is like instructions. This is very low level language. Structured text programming language, this one looks like high level language, equations, table manipulations, and complex algorithms like if, then, or, nor. All these bits we can use in structural test ST language. When it comes to the graphical ladder language, in this language everything is represents in like graphical, like normally open, normally close, coils, like this. But in this language there is limited functions. Next one is functional block diagrams. In functional block diagram, this is easy way to programming, but there is a limited for complex algorithms. And next one is sequential function chart. This one is like a graphical method, represents sequential control systems like steps. CPU memory organization. In Siemens, CPU memory divided in blocks like OB, FC, FB, DB, SFC, SFB. These blocks you can use in logic design. OB is like main organization block, also called main block, in other way like main routine. FC is function, it's like also called subroutine. FP function blocks is like add-on block. DB data block, creating memory. We can use memory tags, we can create data block, and this data block we can use memory like memory tags, word, double word, bit. SFC and SFB function blocks, predefined system function blocks. These function blocks we can use in the logic design. Now we will see Siemens addressing. We will see PLC addressing. PLC addressing is two types, digital and analog. If inputs and outputs are connected to modules, that is physical addressing. If you are using within the program, that is called memory addressing. In memory addressing, we can classify as bit memories, byte memory, word and double word. From this tree, we can see the memory addressing. One double word equal to 2 words. Again, if it is one word is 2 bytes. 1 byte equal to 0 to 7 bits. Siemens, the input side will indicates letter I and output side letter Q. Addressing starts with I 0.1, I 0.2, I 0. If it is another IO module, I 1.1, I 1.2, like that. If it is output side, it will starts with letter Q and Q 0.1, Q 0.2, Q 0.3, like that. That is for digital. For analog input address starts with PIW and output address is PQW. We will see about this addressing while programming instructions. We'll see memory bits. In memory bits, like for bits like digital, we can use AM, and for bytes is MB and MW, MD. M means bit addressing like input addressing. For example, we'll see here bit level addressing is M0.0, M0.1, M0.2, like that, M0.7. M02 and 7 is 1 byte. So after 1 byte, we'll use M1.0, M1.7, like that. Suppose if it is memory byte, we can use MB0, MB1, MB2, MB3, like that. This is 0 to 7 is 0 to 7 bits is 1 byte. So we'll use MB0, MB1, MB2, MB3, like that. Always need to be careful. In Siemens, follows overlapping memory area, so users should be careful in using this address. For example, if you are using MB0, you should not use M0.0, M0.1 until M0.7, because already you used MB0, that means 0 to 7 bits. So you should use after 7 bits, that means you can use M1.0. If you are using MB1, you should not use M1.0 to M1.7. Similarly, if you are using word level addressing, the word level addressing is 2 bytes equal to 1 word, that means 16 bits. For example, if you are using MW0, that means you should not use MB0 and MB1, that means 16 bits you should not. Similarly, if you are using double word, that means 32 bits. If you are using MD0, that means you should not use MB0, MB1, MB2, MB3, and you cannot use MW0 and MW2. Next video we will see about configuration, how to configure the PLC CPU input module, output modules with simulation.